Hi, this is Algebra 1B, Part 2. We are looking at Unit 3, Rational Expressions and Functions, and we are doing the sample work assignment, which is the vocabulary from the unit. I'll go unit by unit, looking at each of the key words. We will write each word, define each word, and give an example of each word. The assignment for sample work is for you to write each of these down on a piece of paper yourself, and then to take a picture of your work and turn that in by putting it in the drop box. All right, so let's start with Lesson 1. Lesson 1 is simplifying rational expressions. And it does not look like there are any keywords. Yep, there are 2 keywords. Here we go. Excluded value and rational expressions. Excluded value. Excluded value. I had to think for a second about what that was. But in the context of rational expressions. Excluded values are values that are left off. And they're left off because they result in division by 0. You can't divide by 0. So values that make the denominator equals 0. Example, 5 over x plus 2. X equals negative 2 is excluded. Because negative 2 plus 2 equals 0, and it would cause division by 0. If you ever want to create a little bit of fun, I'm going to bring up my Windows calculator and show you. If I tried to do 5 divided by 0, I'd get an error message. 5 divide 0. Cannot divide by 0. I can try it in Desmos. Bring up a graphing calculator, Desmos. You try 5 divide 0, it says undefined, and that's the proper term. It is undefined. It is something that can't happen. Okay? So excluded values are values that make the denominator 0. So we exclude them, we count them out. And we say x cannot equal negative 2 with an equals with a slash. Okay, rational expressions. Rational expressions. Okay. Algebraic, meaning with x in it. Expressions. And I'll simplify this as fractions. An example is x plus 2 over x minus 7. That's a rational expression. It has x in it, but it's a fraction. Okay, that's lesson 1. Lesson 2, multiplying and dividing rational expressions. Keyword, complex fractions. Complex fractions. It's fractions within fractions. So you have fractions in the numerator and or the denominator. So x over 5 plus 2 over x over 7 minus 5. That's a complex fraction because it's got fractions in the numerator and fractions in the denominator. Complex fractions. Okay, that's the key word there for lesson 2. Lesson 3 on dividing polynomials. Keyword polynomials. Polynomials. Okay. Algebraic expressions. Of the form ax to the n plus, I'll call it a1 x to the n, a2 x to the n minus 1 plus a3 x to the n minus 2 plus a4 dot dot dot. Okay. Example. 5x to the 5th minus 3x squared plus 4x plus 7. That's a polynomial expression. They have coefficients and variables with exponents. Only whole number exponents are allowed. Okay, lesson 4, adding and subtracting rational expressions. Keyword, rational expression. We've already defined that, so we won't define it again. Then 5 is mid-unit review. 6 is solving rational equations. Okay, and we have a rational equation as a keyword here. Rational equation. It's an equation with a rational expression, with rational expressions. For example, 5 plus x over 2 minus 5 or 4 over x plus 3 equals x divided by 7. That's a rational equation because it has fractions in the equation. Okay, that's lesson 6. Lesson 7 is on inverse variation. Keywords, constant of variation. And I will say slash inverse, because this is the constant of variation for inverse variations as opposed to the constant of variation for a direct variation. Okay? It is the k in y equals k over x, or yx equals k. Example, we can have the inverse variation y equals 3 over x, or y equals 12 over x. And the graph of an inverse variation is a hyperbola. It looks like this. Okay, inverse variation. Okay, and that's variations of the form y equals k over x, or yx equals k. And I've just given you one. And a specific example. Okay, that's lesson 7, inverse variation. Lesson 8's a review, so no new words. That is all the words for Unit 3. Rational expressions and functions.